solving equations section 6.3 is where we have to go beyond like the basic solving of equations, where we can do inverse operations in reverse order. Here we've got an equation with secant squared is equal to 4 tangent plus 6, and we want to solve for x between 0 and 360. So the things that are going to happen in 6.3 is we're combining solving equations with solving trigonometric equations with solving other kinds of equations that we know. The important characteristic here is I've got a secant squared and a tangent. We know that secant and tangent are related with a Pythagorean identity. So this is the first thing that we want to notice. I want to notice that there's a secant squared and a tangent. So I might want to have just one trig function. That's always best if we can get down to one trig function. So we just have to remember our Pythagorean identities. So we'll grab our memory. And we'll try to remember our Pythagorean identities. Just like grab it. So I'm like looking into my memories and thinking, oh yeah, tangent squared theta plus 1 is secant squared theta. And I just remembered that because I have an excellent memory for all. Oh, shoot. So I know that tangent squared theta plus 1 is secant squared theta. So I'm looking at the secant squared theta, and I'm going to replace that with tangent squared theta. Well, x plus 1 is equal to secant squared theta. X. The reason that we're doing this is because I don't like that there's a mix of trig functions. I don't like that there's a secant squared and a tangent running around. Now, forget that. I want one trig function. So the purpose of replacing the secant squared with tangent squared plus 1 is that this will give us one trig function. I'll have that trig function squared, and I'll have that trig function by itself, but at least there will only be one. So secant squared is tangent squared plus 1, and this is what my equation looks like now. Now this is what's equal to 4 tangent x plus 6. Then what we notice is that there's a tangent squared term and a tangent term. So this is set up as being quadratic in tangent. So the next thing that we notice is that there's a tangent squared term and a tangent term. That makes us think about quadratic equations. So we're thinking about ax squared plus bx plus c equals 0. So because there's a tangent squared and a tangent, that makes us think that this equation is quadratic, but instead of just x, it's going to be tangent. But our strategy for dealing with quadratic equations, when there's a squared term and a regular term, a first power term, is to get everything on one side. So I want everything on one side equal to 0. So I'm going to write tangent squared minus 4 tangent 1 minus 6 is minus 5 equals 0. So our strategy for dealing with quadratic equations is to get everything equal to 0. So our quadratic strategy is to set everything equal to 0 and then try to factor it. it's harder to see the factoring when the problem's all written out in tangent. So we're imagining something squared minus 4 something minus 5 equals 0. So I'm thinking of the problem as just something squared minus 4 of that thing minus 5 equals 0 to help me factor it. So now I want factors of -5 with which I can make -4. Factors of -5 whose sum is -4. I spelled 5. I spelled 1 wrong. So if we just replace tangent with a big T for tangent, you want factors of -5 whose sum is -4. Correct. Multiply to -5, add up to -4. So this turns into 2 equations. So our strategy for quadratic strategy is set equal to 0, try to factor, and then set each factor to 0. Use the 0 property. Which is to set each factor to 0. If the product of 2 things is 0, one of them has to be 0. That's the only way to multiply to get to 0. So this tells us that t is equal to 1, a -1, or t is equal to 5. But t was just standing in place for tangent. So I actually want to solve tangent of x equals -1, or tangent of x equals 5. So if t is -1, I'm trying to solve tangent of x equals -1. And if t is equal to 5, I'm trying to solve tangent of x equals 5. I want to solve for the x between 0 and 360. That tells me that this problem is to be done in degrees. So I'm just going to grab my calculating machine and find the tangent inverse of 1. And it's I want degrees. 45 degrees in the quadrants where tangent is negative. So x equals 45 degrees. First, we'll do reference angle. Our reference angle is 45 degrees. We want quadrant 2 and quadrant 4 because tangent is negative in quadrant 2 and 4. I need to cut you off from the happiness outside. This is math class. I'm not going to get any of that happiness around here. 45 degrees in quadrant 2 is 135. And 45 degrees in quadrant 4 is 315. Then tangent of x is equal to 5. So I'm going to inverse tangent of 5. And I got 78.7 degrees in the quadrants where tangent is positive, and that's quadrant 1 and quadrant 3. So 78.7 degrees in quadrant 1 is 78.7. And 78.7 degrees in quadrant 3, we just add 180. 258.7. By the sign, tangent and positive means quadrant 1 and quadrant 3. We got to remember what's positive where. And all students take calculus. So all are positive in quadrant 1, sine is positive in quadrant 2, tangent is positive in quadrant 3, cosine is positive in quadrant 4. The problems that you experience in chapter 6, section 3 are going to be combination problems. So instead of just having an equation with an x, it's going to have an equation involving a trig function. So you have to do your algebra techniques to solve the equation, and then you're going to have to do your trig techniques at the end. And like in this problem, you have to do trig identities to put the to get everything in terms of one trig function. See what wonders the next one holds. So in this problem, secant squared x plus tangent x on the same. So this is going to be involve the same stuff. We have secant squared plus tangent plus minus 6 equals 0. So this is a 6, section 3, problem 2. This is involving the same stuff. So we get secant squared x plus tangent x minus 6 equals 0. So because we got these squareds and the regular trig functions, secant to the second and tangent, we know that secant and tangent are related. So I'm going to replace secant squared the same way I did last time. Secant squared is tangent squared plus 1. The tangents, this is going to be quadratic in tangent, so I'm going to want it equal to 0 like we have it. So I'll have tangent squared plus tangent minus 5 equals 0. The plus 1 and the minus 6 will make the minus 5. Now we're in the same place that we were in the previous problem. We've got an equation that's quadratic in tangent. The difference here is that we don't have something factorable. There aren't factors of -5. Well, there aren't rational factors of -5 whose sum is +1. So this is not factorable in tangent. We're looking at the t squared plus t minus 5 equals 0. which is not factorable over rational numbers. Nope, we're all done simplifying. So we're gonna have to solve either with the, we could use the quadratic formula, or if we forgot the quadratic formula, we could use completing the square. Your question goes to the same thing. You complete the square to get the quadratic formula. So then is when you realize that apparently you wiped the memory on your calculator. So you no, I don't want to. So we take half of the coefficient of t, that's 1/2, and we square that to get 1/4. I did a squared trinomial, t squared plus t plus 4 to the t plus half squared, and minus 5 minus 4. So now I can add the 5 1/4 to both sides, take the square roots, and then subtract 1/2. So t is a negative 1/2 plus or minus the square roots of 5 1/4. I'll call it 21/4 to make it more calculator friendly. So the reason we're going to get 4 answers is going to be similar to the why we had 4 answers before. So we're going to get these two. We're going to get two things. We're going to get tangent of x equals 1, -1, and tangent of x equals 5. Each one of those will lead to 2 answers because tangent will be positive in 2 different or negative in 2 different quadrants. So each one will make 2 answers for 2 quadrants. So 2 numbers, 2 quadrants per number. Oh, no. Now that's why we'll have 4 answers. I'm mad that I deleted my quadratic formula. It's annoying because I don't really like the quadratic formula, which is why I programmed it in the first place. And I'm pretty sure that this is as efficient as we're going to get with the quadratic formula. So program cute. A is 1, B is 1, C is -5. So 1.79 and -2.79. Let's double check. 0.5 plus the square root of 21/4. Oh, -0.5. -0.5 minus the square root of 21. So we get these 2 values for t, but this is just the values of tangent. Tangent of x equals the 1.79 and tangent of x equals -2.79. So this gives us 2 things. Well, let's write down these 2 numbers. So I'm in this situation up here. I've got tangent of X is 1.791. And over here, I've got tangent of X is negative 2.791. So I'll do tangent inverse of, I'm going to do the negative one first because it's right there, which is a negative 70.3 degree angle. And that's going to go in quadrants 2 and 4. So X is 70.3 degrees in quadrant 2 and quadrant 4, because 2 and 4 are where tangent is negative. So 70.3 degrees in quadrant 2 is going to be 180 minus the 7. Oops. That's going to give us a 109.7. And 70.3 in quadrant 4 will be 360 minus 70.3. And then from the 1.791, want the tangent inverse of that. There's my reference angle of 60.8. And we're going to put that in the quadrants where tangent is positive. That's quadrant 1 and quadrant 3. So that gives us one answer of 60.8. And quadrant 3 will be 60.8 plus 180. So we get two values for the tangent because the equation was quadratic in tangent. And then we get two values for each of those two different tangents because tangent is positive or negative in two different quadrants. They could have, if they both ended up being negative, these two values had both been negative, we still would have had 4 answers. So unless it came out to the same value, 1.79 twice, let's say. Yeah, we had two different reference angles, and each reference angle goes into two different quadrants, and that's why we had 4. So it's not necessarily positive or negative. It's just that we had to come up with each of these two different numbers gave us two different reference angles, and each reference angle gets placed into two different quadrants as we were solving for everything from 0 to 360. So here's a treadmill problem. This is thinking way too much about treadmills, but we have, here's an equation. Keith's speed can be modeled by the equation, whereas Kevin's speed can be modeled by the equation. During the first 10 minutes of their workout, at what times are they both going the same speed? So I don't know why they're regulating their speed so carefully, but it's not important. When are the speeds the same? So just take the 1.7 plus 9 sine t equals 1.7 minus 8 cosine t, set them equal to 0, or set them equal to each other and solve. It's going to be an equation involving sine and cosine. So we'll want to find a relationship between sine and cosine, put that into the equation, and solve. Try to write it in terms of one trig function if you can. Any questions? So all that talking, all that writing, it's like, when are they going the same speed? One of the speeds is 1.7, 6.3. One of the speeds is given by 1.7 plus 9 sine t. And the other speed is given by 1.7 minus 8 cosine of t. It really bothers me that we have two different speeds, both with the same name S, and that they name these people Keith and Kevin. Stop with the same letter. Especially because they're both KE. And they both have an I in it. I know the I is not in the same place, but one of the I's has a T right next to it. I'm supposed to be able to read this. I don't know who checked this for accessibility, but sleep on the job. Yep, we're just going to put them equal to each other and then try to solve. Oh, this is what happens if you mess up and you have to erase it and get rid of some of the things. It becomes all shiny and hard to write on. Notice that the 1.7s drop out. So remember our strategy is to try to get one trig function if we can. I got this mix of sine and cosine, and that's making me annoyed. But if we can get one trig function, then we'll be better off. We know that sine and cosine are related with the Pythagorean identity, but these are just sine to the first and cosine to the first. And that's going to involve square roots, and that's going to make me annoyed. So this is when we notice a cool thing happens. What cool thing happens in the first thing we're going to take care of in this equation? What's something that doesn't matter in this equation that we can get rid of to simplify our lives? 1.7. Both sides of the equation are like all 1.7. We're going to subtract 1.7 from both sides, and that's going to give us a much easier equation to work with. Because now it just says 9 sine of t is equal to negative 8 cosine of t. The reason that this is better is now I can make one trig function by dividing by cosine of t. If I divide by cosine of t, that means I'm going to get tangent of t, and I don't have to use any square roots. So once I saw those two 1.7s there, knowing that they were going to cancel out, we became much happier about this problem. I don't know if y'all are happy about those 1.7s canceling out, but you should be happier about those 1.7s canceling out. So look happier. Much better. So now now that I've only got one term on each side, I can make a proportion. I'm going to divide by cosine. And I'm actually going to move the 9 over to the other side, because now I can write tangent of t is negative 8 over 9. Now, another thing to note is that we want to know what times this happened, what times the speeds were the same in the first 10 minutes. So we're solving for t between 0 and 10 minutes. Once the problem is, we're solving for t in minutes, that takes the problem out of degrees and puts us into radians. We're only going to solve in degrees when we're specifically looking for angles in degrees. We're not going to have t between 0 and 10 degrees. We want 0 and 10 minutes. That's an indication that this problem should be in radians. Tangent of t equals negative 8/9 is going to give us a reference angle, and we're going to start putting that in quadrants, and we're just going to add the period each of those until we go before 0 or after 10. So my reference angle Oops, I just said per inch radians. 0.727. And it's negative. So we're going to go in quadrant 2 and quadrant 4. So the quadrant 2 angle, is going to be the reference angle, pi minus the reference angle. Yeah, the reference angle is 0.727. And the quadrant 4 angle I'm going to get my reference angle back, is going to be 2 pi minus the reference angle. No, they're positive because I'm just finding the reference angle and putting it in quadrant 2 and quadrant 4. I picked quadrant 2 and 4 because tangent is negative in quadrant 2 and 4. If I want the negative versions of these angles, I'd have to have like negative 0.726, but negative 0.726 is not in the range that I'm looking for. When we look at the set of answers, it says that we have to put in 3 answers. I've got the 2.41 and 2.41, and I've got the 5.56, but where's this 8.7 come from? So the 2 answers that we got are just going around 1 time. Those are the answers between 0 and 2 pi, or 6.28. But the period of tangent is pi. So I have to add multiples of the period. So if I take the 2.415 and add pi, we get 5. Oh, that's the 5.56. So we have to add pi again. 8.698. If I add pi one more time, I'm past the 10-minute mark, and they only went for 10 minutes. So 2.415 plus pi is the 5.557. And if I add pi again, we're at 8.698. And if we add pi again, we're at 11.83. 840. But this is past 10, so we don't care. There was an answer that came before the 2.415, but if I take the 2.415 and subtract pi, that happened before 0, so we don't care. We only need the values of t that'll happen between 0 and 10. The general strategy for solving these equations is to try to get everything in terms of one trig function. And you're going to have to use all of your algebra skills to get that. The first 2 involve using trig identity, and it resulted in a quadratic equation. But after that, it was the same thing. You do an inverse trig function to get your reference angles, and you put those reference angles in the appropriate quadrants. How's everybody okay? All right. That's gonna do it for today. We will do some more problems on Thursday. Everybody have a good couple of days and thanks for playing.